Hello, Peter.
Hello. I'll get
Hi.
started then.
How's it going?
It's going very well.
Yeah.
Um, I too am, of course, remote. Pity that I couldn't make it to an in-person event. Of course, this is unavoidable, but I'm very excited.
Yeah. First of all, thank you for joining us today. And so, are you ready? Good to go right now?
I'm ready. Yes.
All right. So it's all yours. Good luck.
Great. Okay. So this talk will be a little different to the one you just saw. This will be more technical in nature, and it concerns recent work of mine in one particular area of the PostgreSQL code. Like Peter Eisentraut, I too am a PostgreSQL contributor and committer. My focus is a little different, as you would expect. I principally work on indexing and that is available in PostgreSQL 13, which came out about a month ago, and you can download as a stable release today. And then at the end, we'll talk a little about more upcoming work in the next few months, the next year, which is highly related to the feature introduced in this year's release. So moving on. The name of the feature is B-tree deduplication. It is as the name suggests, it is a way of teaching the standard B-tree index access method more efficiently represent keys in perhaps a simple or obvious way. Namely, rather than storing a key and after that we store a list of items in the table to which the key points to. So this is fundamentally a simple idea. So this particular item was something that I worked on with another contributor, a lady named Anastasia Lubenakova, who is based in Russia. She originally started on this project, I believe it was 2015, and was only successful ultimately in getting the project accepted in really early this year. And so this was a significant effort, an effort that evolved over time, and an effort that I think will speak for itself as something very useful, and I'll explain why now. So really the idea is to, as I say, to simply store key in each index only once, rather than this is notably something that occurs that is to say that we do not initially store the same key together. We wait for a little while. So the same initial representation is used as before, but then after a period, we will merge them together. So you can think of this perhaps as being a little bit like a bitmap index. In particular, Oracle. However, I like to say that it's quite different to Oracle in that it doesn't change the fundamental locking characteristics of the indexes. So in Oracle, it is well understood that if you have a bitmap index, it's only suitable for data warehousing for analytics, because the locking that is required on the indexes is quite a strong form of locking. So it becomes impractical to concurrently modify data to the extent that it is simply not possible, really. So people understand with Oracle that you simply use bitmap indexes for data warehousing and things like that, and that's what they're good for. And it's not possible with the bitmap index to use it with a mixed workload. Whereas this design is notable because it has many of the same advantages, but also doesn't have the disadvantages that we see in Oracle. So it is, in some sense, the best of both worlds. Okay, I'll proceed. All right, is everyone caught up? Are you current? I'm going to take that as a yes. So here we see a very simple example to give you some idea of the level of space savings that we're talking about. This is a performance improvement, certainly, but it's more than that, I think, an improvement in efficiency. I believe that efficiency will become increasingly important for PostgreSQL. So this is part of that. We see on the left here an example TPCH data set with standard indexes for that benchmark. TPCH is an industry standard data warehousing benchmark. And here I'm not focusing on the result, I'm simply focusing on the state on disk size of the data. And because it's data warehousing, there tends to be naturally a relatively large number of duplicates for each value. So here we see approximately, the size is reduced to, so it's almost 3 times smaller. It's about 36% there. On the right, this is a public data set. It's used for medical research, genomics. It's called the Mouse Genome Database. So it's a database which, as I understand it, has special scientific and medical information relating to mice. And this is more mixed. I use this example purely because it was available. And so this can be verified easily. It just so happens that there is an open source data set that was available that was specifically PostgreSQL, that specifically used these indexes. So I decided to, for no other reason than that, to use this example. Now, what I'm talking about here is all of the indexes, not the table, all of the indexes taken together are here about 59% in the case of the Mouse Genome Database, and in the case of TPCH, like I said, 3 times smaller. There are unique indexes in the Mouse Genome Database. It's kind of, it's not a pure data warehouse database by any means. These are variations that will quite obviously be based on the distribution and cardinality of data. And the reason I haven't shown an absolute size, the reason I'm putting percentages and not gigabytes is it doesn't really matter what the gigabyte size is. Either way, just based on the cardinality of the data, the proportion of distinct values for each logical row, that alone determines the size differential. So any size will be reduced by a comparable amount. Okay, so this is a more extreme example where this is an example that is very, very optimistic in the sense that you probably won't get such a big change, but it is possible. So this is not realistic, but it is an example of what's possible. This is test data that came from it's the UK Land Registry. So it's a database it's a database that contains information about real estate sales in the United Kingdom. It doesn't really matter, but it just happens to be very, very low cardinality. So you see a very, very large decrease. In fact, the extent of the decrease that you will see is something that you could guess based on intuition, because it is what I said. It is duplication. So the question is it's entirely a matter of the distribution of your data. I think this is just not difficult to understand. So when we were working on this, we were very concerned about preserving the existing characteristics of the B-tree access method. After all, people are using this all the time. People are almost definitely using the B-tree access method because it's used by default. If you don't ask for a specific type of index, so if, for example, you don't ask for gist or gin or any of the more exotic types of index, this is what you get. So this is sort of something that really we cannot afford to lose any performance in other areas that we're not concerned about when we go to enhance it. It has to be at least as good as it was in every way and not just in most ways. So we try to do this by keeping the representation simple, and we don't, for example, compress the list of row IDs. It would be quite possible to do that, but for the reasons just stated, we choose not to. We're trying to, with the B-tree access method, we're trying to give a very balanced set of performance characteristics, very general purpose, something that's useful for many different situations and can be used with relatively little concern about what it may be not so good at. So it's the everyday index, you could say, and that makes it harder to work on, but I think also, for obvious reasons, more rewarding. Now, it should also be said that there is another way that you can look at the deduplication work. The deduplication work is something that does primarily exist in order to make indexes for data warehouses and things like that, in particular, smaller and to make things more efficient, as I said. But it also helps with it also helps with the implementation of MVCC. As some of you, I imagine, know already, MVCC stands for multi-version concurrency control, and it's the method by which we control concurrent access to data in PostgreSQL and indeed in many other systems, including, for example, Oracle. So rather than locking rows, we're making snapshots. We're maintaining multiple versions of the rows concurrently, so that readers don't block writers and writers don't block readers. A very important characteristic. So this design also ameliorates some of the problems that we have when we have multiple versions of a row. So we have multiple entries in the index sometimes that pertain not only to the that pertain not to the say so there's not one logical row for each entry in the index. Sometimes there are multiple entries in the index for only one logical row, of which multiple versions exist at the same time. So this naturally helps with the situations where that occurs still. And this leads me onto the second bit of my talk, where I'm talking about the upcoming work. There was a famous blog post written by a company that I believe maybe had operations in Korea at one point, if they don't still, Uber. They were complaining about something they called write amplification. So this, and right application means what I just described. It means that there are multiple entries, physical entries in the index, even though there's only one logical row in the table, only one row to the application, to the user. Now, what I'm working on right now is a variation and a further enhancement of deduplication, namely what I'm currently calling deletion deduplication, which is probably not a great name, but this is very much something that's happening right now, so I didn't have time to think of a good name. So this is something that works in a based on similar principles to deduplication. So rather than deduplicating in the way I described, it considers the question of whether or not we could discard old versions instead of combining them together. So we have a choice. And sometimes that can be very important when we're doing low-level optimization and we're doing low-level performance work. If we can allow the implementation to have many choices, ultimately the implementation will make different choices in different situations, and we cannot really predict what situation we'll have. So having a variety of techniques that we can use to deal with these problems is, I believe, very valuable. We will eventually find, the implementation will eventually be able to use a very good solution. It will get to an almost optimal solution, but it needs to be able to try different things and find which is the best one. That's how I like to think of it. That's how I like to describe it. So we're now using this to also avoid what I call logically unnecessary page splits. That is, page splits caused by write amplification, page splits caused by new versions that are continually added to the page. So it's kind of I guess you could say that it's sort of it complements the existing vacuum functionality by, you could think of vacuum, say, as being a top-down approach to garbage collection. This is more of a bottom-up. And again, here we have optionality. Hybrid approach is often the best way to go. So that would also apply at a higher level with vacuum and this and other things I could go into, but won't also. Oh, okay, so getting on to some conclusions. When you heard from Peter Eisentraut earlier, he was talking about how there's a lot of innovation in Postgres indexing. And the way it works, I think, is the way that the concurrency control of the system works helps with that. So it's not really something that we really talk about a lot, but in fact, it gives us a lot of, the design that we have gives a lot of flexibility and it enables innovation. And I'm very pleased to be a big part of that now. This will be my third very big B-tree project in 3 years. So I'm kind of just doing that for the last 3 years. And it seems to be going very well. So it's worth sort of addressing, it's worth pointing out that we're addressing some of the problems we have still that most people will not encounter anyway. But there are some problems with the way we do MPCC in some situations for some applications, and those things are things we're actively addressing and things that are getting better all the time, and things that will continue to get better in the future. So we never stop with that. We never become complacent. At least I hope not. And I believe that's all I have for my main slides. Hopefully that was clear. Do we have questions?
All right, that was fantastic, Peter. Once again, thank you for joining us.
Oh, well, thank you for the opportunity. As I said, I greatly appreciate it. it is, of course, a shame that I can't be there in person, but you know, you do your best. There will be other opportunities. The world will go on. So.
I get this feeling that I might see you next year in Korea.
Well, I'm trying to suggest it in a very subtle way that maybe you know, you missed. If I'm trying to like hint at it very subtly.
Right.
I've never been to Korea. I would love to go. And I can say sincerely that Peter said something earlier, again, the other Peter, about how it's curious how there's a lack, what would seem to be a strange absence of representation from Korea. There's no good reason why there should be. And I hope very much that perhaps my appearance today will make some small contribution towards maybe creating more on the ground organic interest in PostgreSQL in Korea. Let's see.
Yep. All right. So we have a couple questions to you. So first one is, we recognize that there, you know, version numbering has been changed over years. Previous numbering was using decimal points, like 9.1, 9.2. So it took quite a while to get to from version 9 to version 10. But then, you know, past 5 years, you guys were releasing like version 10, 11, 12, now 13, which seems like more major numbers right now. So do you have any idea or what it's, why it has been changed? Like, does it mean anything to you? Because since you work in, you know, you contribute this community for like 20 years, I think you have an idea. So can you answer that?
Sure. So I think you could say that it's a little similar to the situation with the Linux kernel. Some people may recall that for many years, the Linux kernel was called 2.6 point something. And this was the case for a long time. I don't know exactly how long. It might have been more than 5 years. And they were just, it just didn't make any sense anymore because it was just, they weren't changing the bigger numbers, even though there was really no reason why they shouldn't. I think for us, we originally thought that, oh, in order to have a major version bump, there must be a major feature that justifies such a change. We tend to be quite conservative in these matters. Sometimes that's good, sometimes that's bad. But the thought was, well, we have to wait for the next big thing. The big thing that made PostgreSQL 8.4 become PostgreSQL 9.0 was hot standby and streaming physical replication, which is a big deal. That was a huge change. But as the system matured, it became clear that even though we have lots of big features most years, you can only have so many enormous features. So that whole system became obsolete, and it became clear that the old system wasn't working anymore. And so we simply decided to stop using that system and replace it with, so rather than going from, what was it, 9.6 to, you know, 10.0 and then 10.1 and then 10.2 for each year, we simply said, forget about the number in the middle, cut that out, just go major version and then the point release at the end. Point release being the approximately every 3 months we have in any stable release, we'll have a point release which has patches and bug fixes and stuff like that. So that's what the second number is, and the first number is just the major version. So it's just an accident of history that we had a system and then we changed it. It's not particularly relevant to the quality of the product or anything like that.
All right. So I have a question to you, Sean. What version did the ExpertDB start to use with?
Yeah, I remember the very first version of ExpertDB was based on Postgres 9.6. At the time, we have, I think we have like streaming replication and hot standbys and also PG rewind function, which in some cases will be really useful to make the database cluster back online.
All right. So here comes to you once again, Peter. The second question is, during your session, you mentioned that due to improvements in deduplication, the index size has been dramatically decreased, right?
Mm-hmm.
But how about the performance-wise? Was there any performance improvements because of this, or do you have any statistical data that back up this theory or like proves it?
Yes, I can. I alwaz prefer to think about, in general, I prefer to think about when I'm thinking about this stuff. I like to, rather than thinking about it as making something better, I prefer to think of it as taking something bad away. So here, I think the bad thing was if you had, say, an index that happened to have a big key, like a text string that was maybe 30 characters long on average or something like that. Mm-hmm. And you had a lot of updates that could cause a lot of churn in the indexes. I don't recall exactly what, I think it was about a 7% improvement on TPCC. That was going from, what was it, from 12 to 13. And actually that was independently verified by an engineer at Enterprise DB. Although it wasn't attributed to my work, I'm pretty sure that's what that was. So an engineer at Enterprise DB there was a recent blog post by somebody who showed that indeed the standard OLTP benchmark was improved at high client counts. I think he tested it at maybe 250 clients, and that was 20% faster. So I don't remember the things that I don't really remember the things that get better. I more think about things that were bad and are no longer bad. That's just, I think maybe that's my personality, that's my process. So I don't have, I think that's correct, but I'm not sure. So about 20% in good cases for TPCC. You could Google the benchmark Enterprise DB PostgreSQL 13 and you'll see.
Mm.
So,
all right. Do you have any thoughts or comments on this?
Yes, well, actually I have. Sometimes when I feel like I need to contribute to the Postgres, I translate some of the release notes into Korean. So I usually post it on my blog. So the only post I have been done about the Postgres 13 is actually the B2 index deduplication. So yeah, I checked how many when there's a low cardinality, how much spaces we can save, and each single index scan, the performance is getting better. Yeah. So yeah, I think
right.
Yeah, I understand what Mr. Geoghegan talked about.
Mm-hmm.
Yeah.
Mm-hmm. So it's that important. Huh?
I think it's probably most. If I was to try to describe it in a very short period of time, which I'm not good at, I would probably say the best thing about it is it's more efficient. Many people today can afford very fast SSDs, many of which are made in South Korea, I should mention. And these are excellent devices, but on a per gigabyte basis, the cost is not low. So in aggregate, the performance benefit, I would say, is more from your ability to afford to use a 1 terabyte SSD, where that wouldn't have been the case. If you can save on disk storage without really anything bad happening to your application, then you will in effect get a performance improvement by affording to use faster storage. So I always prefer to think of it in, I mean, it is interesting, of course, to give a simple number, and people always want that, and I agree that that is useful, but I think it's become more useful to think about it as a question of efficiency and a question of how it fits into your existing workload and your existing data center spend, your servers, etc. That I think is the best way of describing it. So I would just point that out.
All right, so here comes next. One of the good thing about the open source is actually anyone or everyone could just join it and contribute it, right? And but since it's anyone, I mean, random people could just go in there, you know, throw some data in there, and you know, but you have to keep it clean, right? So how do you keep the PG stable?
That's a great question. Of course, there is no one answer. Or if there is one answer, I'll try to keep it simple because otherwise I'll never stop talking. If there is one simple answer, I think it's this. There is a culture of responsibility, certainly on the part of PostgreSQL committers, who are in many ways the last line of defense. There is a way in which there is personal culpability for mistakes, and there are some things about radical transparency, such as you see in the PostgreSQL community, that are difficult, but it also has very real benefits. So it could perhaps appear to someone from the outside looking in to be a bit of a chaotic process, and maybe in some ways it really is. I don't pretend that that's not true at all. However, I also believe that sometimes the most stable process that produces the best result over time, at least, is a bottom-up process where the primary determinant of quality is someone taking a personal responsibility for something publicly. At the very least, it's my observation, my experience suggests that really works. So I'm happy that we have the culture that makes this possible. Things that work sometimes work for something in a way that's very difficult to summarize, because it's not what one person did, it's what everyone did together that created an effect together. So it's not something that can be summarized so easily. If that sounds strange, well, then perhaps you just have to see it for yourself, and you can. So if you want to, please do. To me, it feels very normal to have a huge amount of transparency. It's what I'm used to now, but I forget that other people don't have the same situation. Yeah. But which probably sounds very strange, but that's the truth, you know.
All right. Sean, do you have any project that you had, you know, dealing with the stability or, you know, security stuff?
I don't think I can say yes, but I'm hoping one day I can actually contribute to the Postgres community, because I'm actually feeling like I feel like owed to the Postgres community, because of existence of the Postgres, I have like wonderful chance to have my own skills and stuff like that. So yeah, I'm definitely trying to contribute to the Postgres community.
Yeah,
some
near future.
Yeah, near future. Yes.
Yeah.
That would be great. Of course, it is a little more difficult, I suppose. I wouldn't know, for someone who doesn't speak, whose first language is not English. But on the other hand, there are many people in that same situation, so you certainly wouldn't be the only one. I think that it's important to just try and to see what works and figure it out organically when dealing with these things. Again, I forget what it was like when I was starting because it was a long time ago, but I believe that it's just a matter of not being too self-conscious and being earnest and being engaging in the spirit of cooperation and all that sort of thing. That tends to lead to good results. So I'm very happy to hear that maybe there's more of that kind of interest in Korea. I say very sincerely, I always thought it was strange that there wasn't at least some, because I know that there is no shortage of people in Korea that are very talented and that in particular know about database stuff. I won't go into details, but I was aware of that and I just thought it was strange.
Right. All right, so it's time to get some questions from viewers in real time. So I have a couple good questions right here. And when converting on open source DBMS, I'm curious about what is important to prepare in advance. So I think he's trying to, switch from commercial DB to open source DBMS. So what does he have to prepare in advance? Like that's what he's trying to say.
Okay, good question. I think maybe the big difference, if you're a user that is used to a proprietary vendor, is if you're using a proprietary system such as, we'll say Oracle, because it's the classic example, you do expect that Oracle will be one point of contact for you. So for example, you'll use a backup software that Oracle produced directly that is sold to you at the same time by the same people and is generally understood to be exactly the same thing, really. It's a little different because of the decentralized nature of PostgreSQL. There are a few tools that are de facto standards, not official, but de facto standards. For example, I think it's fair to say that the PG backrest tool is the de facto standard when it comes to doing backups in PostgreSQL. So there is some overlap. Some of the same people that work on that work on PostgreSQL itself. The point is to adjust perhaps your expectations of the ecosystem being something where there's very, very clear responsibility from on one website with one party, expending everything up front. You will perhaps have to look a little bit further, or maybe not too far, but you have to be aware at least that this is a little different. So that's probably the number one thing I would say.
All right, I get second questions from viewers right now. What is the difference in performance between Oracle and PostgreSQL when they come to scanning the index scanning the context, scanning the index containing the duplicated data?
That's a fair question. The answer is I don't know, but I think it's probably true that if I did know, I could not tell you, because at least in the United States, which is where I live at the moment, I'm in San Francisco, California today. There's something called the DeWitt clause. It refers to something that was added in the 1980s following a dispute with a famous database researcher by this name DeWitt, who did a comparative benchmark with other systems against Oracle. So now Oracle say, when you don't buy Oracle, you buy a license. And the license says, here's what you're allowed to do and here's what you can't do. And one of the things you can't do is to publish a benchmark. So this is why there are no comparative benchmarks available publicly. Because in theory, at least, if someone attempted to publish a benchmark like that, Oracle could sue them, because they're not allowed to do that. It's forbidden. And this has never been tested in court, so we have to assume that that threat is there. So no one does these benchmarks because they're simply not allowed. And this DeWitt clause is standard practice. So all of the proprietary software vendors do the same thing. So I don't know. I presume that the answer is something like, my guess is the answer is we're better at some things, they're better at other things, and whether or not that helps you, whether or not that makes your life better or worse is very hard to say. In the end, unfortunately, you will have to assess this for yourself. There's no simple way, unfortunately. That's how it is.
All right. I think we don't have any more questions, so I think that's it for us. You've been really terrific to us today. Yeah, you're
And
wonderful.
I'm very happy to have had the opportunity to oblige you. It's it's always nice to talk to new people and to have new experiences around the world. So.
All right. I think that's it. We can just wrap it up right now. So thanks once again. Hope to see you in near future.
I hope so too. Here's hoping.
All right. Thank you. Bye-bye.
Bye-bye.